farther, and so that's really what I'm going to applaud when that happens. So that's congratulations to NASA. In fact, tomorrow morning, I'm flying back like immediately after this, interviewing the head of NASA for my radio show at 10:30 tomorrow morning at headquarters. So I'll bring him your sentiments that you appreciated what you just saw. Yeah. Florida as a state is a little closer to this kind of activity than most other states, so as for obvious reasons. Congratulations to Japan. Japan won the trifecta. All 3 Nobel Prizes went to a collaboration of 3 Japanese scientists. This, again, just announced this was 4 months ago or so. We got the Nobel Prize in Physics, and they, I'll read it to you, for the invention of an efficient blue light-emitting diodes, which has enabled bright and energy-saving white light sources. We already had red light diodes, and we had green light diodes. That's the RG. And what do you need? B. We didn't have a B. So they invented the B, and now you have RGB. You combine them in different ways. You can make every single color in the spectrum, and it is that discovery that has opened up the LED interior lighting marketplace. Because you're not going to illuminate your house with green light. You look like aliens. Yeah, you don't look like aliens. Wouldn't that be cool if we only had the green light and aliens visited and say, hey, they look just like us, you know? Oh no, it's just the lighting, you know? So this is an interesting thing. Normally the physics degree goes to some abstract concept that nobody understands except a dozen people in the world. This one had direct commercial applications. And it's transformed the field of interior design completely. I have track light. We modeled our place recently, and I got like a track of light where I just control, it's all LEDs, and I just make it whatever colors I want. I can slide back and forth through the rainbow. It's really cool for about 10 minutes, and then, okay, give me just a straight light after that. But it's really cool that you can do that. So congratulations to Japan. By the way, the sun is doing what it does best. It burps up some of its own material. And you might read about this X-class solar flares, watch out. Yeah, they're dangerous, but the sun has always been doing this. But now we can image it with very high precision. So it makes you think the sun is being extra bad. But that's not really the case. We have a classification system, ABC, MX. That's pretty obvious why we do that. X-class solar flares are the most energetic. If you have a negative exponent, the smaller the number in the exponent, the bigger is that number relative to others. So the X-class exponent is the biggest, and I have some footage of that. So this is a NASA, the Solar Dynamics Observatory, and right where that little bright spot is, just watch it burp up. Here we go. Oh, sorry, I forgot, this has a soundtrack to it. So I won't be able to talk over it, so here it goes. I guess I could mute it. I'll just mute it. Okay, here we go. Will this work? Mute? Nope. That did not work. There's a mute. Okay, we'll hear the music, fine, because it's dramatic music. Here we go. Get more volume there. Okay, that's an X-class solar flare. And the sun just burps itself. It repeats a couple of times. Let's do that again. I like that. There we go. Let's watch it burp up. Okay, you look like, okay, that's just a little thing, Tyson. What are you getting worried about? But if you look at the next image, of course, if you look at this, that's the size of the Earth relative to the size of that flare. So that's a badass flare. Just watch out. Those, when they come to Earth, they can disrupt electronics. That's why modern satellites are what are called radiation hardened. They're resistant to these particles that come that can short circuit the electrical components of it. So, yeah, so let's move on. Mars. Who doesn't care about that? We all love Mars. We still have a rover there, the Curiosity rover, named by children in school. By the way, the NASA spacecraft, in the last 15, 20 years or so, they hold naming competitions among school children. and the Curiosity rover was the one that won. This is an actual image from the actual surface of Mars, where you see part of the Curiosity rover launched from Earth in an awesome hole-in-one. We landed it right, within where we needed it, in a very tiny crater where we think water had come down and settled and then evaporated. So if there's any life or any organics, as we know, life and organics, it thrives on liquid water. So when you're exploring Mars, you want to follow the water. And so that's exactly what this vehicle has been doing. It's still going. Mars has a 24-hour day. It has polar ice caps. It goes through seasons. It has an atmosphere. So it's the obvious first target if we're going to look for life as we know it. Because if you're going to look for life, actually there was a first image taken by Curiosity. I used to be an advisor to NASA, serving on what is essentially the board. And it's called the Advisory Council. And so I have access to NASA. And so there was the very first image taken by Curiosity that NASA did not release. But I got a copy of that. So the very first image is right here. Okay? Yeah, we never need to see me up there, I don't think. It's not about me. But put me up just for a second. Okay. All right. So here's the very first image taken by Curiosity from Mars, and it was not released to the press. I'm still trying to figure out why. I'm thinking maybe it was because it was desolate. If you land here with this rocks and nothing else happened, I'm still studying this photo, trying to figure that out. Pluto. We demoted this like years ago. You okay with that? We're not okay, but I just want you to know that it's still not a planet, all right? And I thought, and how many Pluto lovers are out there? How many? Yeah. Okay, so here, you just gotta, get over it, right? Look, half of Pluto is ice. So that if it were where Earth is right now, heat from the sun would evaporate that ice, and it would grow a tail. That's no kind of behavior for a planet. And did you know, Pluto lovers out there, 6 moons in the solar system are bigger than Pluto, including our moon? And our moon is 5 times the mass of Pluto. That's just embarrassing for Pluto, I would think. So there are really cogent reasons for this decision. And I was involved, I was kind of an accessory to the demotion of Pluto. I didn't pull the trigger or anything, but I surely drove the getaway car. In 2000, very early in this conversation, we took Pluto and organized it in our newly built facility on the universe and put it with other icy bodies in the outer solar system, called the Kuiper Belt of icy bodies. And I think Pluto's happier there, because they all look more alike to one another than any one of them looks like the rest of the planet. We did this. A year later, it took them a year, the New York Times had a page 1 story. Pluto not a planet? Only in New York. That's when the hate mail started coming in. From 3rd graders. Here's an example. Dear scientist, what's it called Pluto if it's not a planet anymore? If you make it a planet again, then all the science books will be right. I said, what? Why is this child worried about the profit margins of the textbook college? Do people live on Pluto? If there are people who live there, then they won't exist. Why can't Pluto be a planet? It's small doesn't mean it doesn't have to be a planet anymore. Some people like Pluto. And if it doesn't exist, then they don't have a favorite planet. But please write back, but not in cursive, because I can't read. Draws of letters like this. Scrawled crayon, pissed off school children. They just finished learning, memorizing the order of planets for the sun. My very educated mother just served us 9 pizzas. I even have letters saying, now how am I going to memorize the planets? And I thought, it took me maybe 3/10 of a second Say, my very educated mother just served us nachos, okay? We're good to go. On to the next problem. Now, this is actually all old news, but what's not old news is that we're on our way to Pluto right now. New Horizons mission, launched in 2006. This year, watch the news. Watch for it. In May, we will be, it took that long, 9 years. In May, we will be close enough to Pluto with the New Horizons mission to photograph Pluto a little better than the Hubble telescope could do, right? This is the best image we have of Pluto's surface, the front and the back. And so it took 9 years for the cameras on board to get close enough to do better than that, and that'll be in May. And then in July, there's the flyby. So it'll be all over the news. And it'll be straw poll, should it be a planet again or not? But you heard it here first. The answer is no. Comets. Europe sent a spacecraft to a comet, and that spacecraft is called Rosetta, named for the Rosetta Stone. And comets contain information about the formation of the solar system, and it's intact. So if you want to decode the chemical signatures of our region of the galaxy, the study of comets would do it, and hence the Rosetta Stone reference. ESA is the European Space Agency. In a day that I might have said NASA, but no Europeans came up with this. And Philae, this little washing machine-sized attachment, deploys from this space probe, and that deployed that deployable piece of it landed on a comet, and it took this picture on its way in. That is a comet surface, dang near right on top of it, and it looks like a big boulder, but in fact, that is all held together by frozen methane, water, and ammonia, mostly water. And so, and when a comet evaporates, all these particles come off of it, and it leaves a stream of debris in its trail. And if a comet crosses the orbit of the Earth ever, there's a debris stream that we plow through at the same time each year, and that's what makes meteor showers. That's why meteor showers are at the same time every year. We're plowing through the debris of a comet that had long ago passed by. Now, how big is this comet? Since the Europeans went to study it, the Europeans made this image, which is how big the comet is relative to Paris. And I'm thinking, if I'm a Parisian, this is not the picture I want to be looking at. This comet we just landed on is so big, it'll stretch from Louvre to l'Arc de Triomphe. Yes, thank you. This is artist gone a little, given a little too much latitude here, I think. So yeah, if that hit, that would be the end of not only Paris, but most of Europe. The comet, as it nears the sun, begins to evaporate. This is an actual photo of it, and those are not just beams of light. That's actually evaporated gases. In fact, literally, the official term is the gases are subliming. They're solid on the comet, and they become gaseous without going through a liquid phase. The technical word there is sublime. So this is sort of the formation of the tail as it comes up, but we see it right up close, which is very cool. Another comet, Comet Ison, that's an acronym for the International Scientific Optical Network. And there are two discoverers, Nevsky and Novichonok. It's never like Fred and Barney who discovered comets. I don't know. Now, here, why am I telling you about this? Because this comet was discovered 2 years ago, in September 2012, and it was going to come around, we calculated its orbit, it was going to be this beautiful comet in the sky around Thanksgiving and Christmas 2013. And it'd be this beautiful comet in the winter skies and with the holidays, and everyone was gearing up for it, okay? But that's not what would come to pass. The comet died on Thanksgiving Day. It just died. Now, how does a comet die? Ooh, I'm going to show you how comets die. Here's an image from the Solar Heliospheric Observatory, another set of cameras facing the sun. In this image, I have to explain it to set you up. The sun's disk is the center circle drawn in white. And the dark shadow, the dark thing, the dark circle is what we call an occulting disk. Because the sun is so bright, it would burn out all the detectors. So you have to blot out the sunlight so that you can see what's going on around it. But we drew in the circle so you know the actual physical extent of the sun. That little loopy-loopy thing is just the sun burping up its material again. plasma is what we call it. The comet is coming in at around 5 o'clock on the right-hand side. See that little blip? Okay. This comet, what are comets made of? What kind, in what state? Yeah, ice water, mostly. And what are stars made of? Hot stuff. Okay, so here's a comet made of ice, making a close approach to a hot thing in the solar system. All right, so here we go. Okay, so the sun is always burping up gases, so just you can ignore that for the moment. Here's the comet coming in, and it's responding to the sun's gravity, and it's going to make a very tight arc around it and come out the other side. But once again, heat and ice don't mix. So here's going to come out on the other side, and the sun just completely messed with it. And what's likely is it broke it apart into many, many different pieces that fully evaporated away at that time. And so there's the comet way out there. Rest in peace. Then the sun shows off and like, yeah! Take that! That's what it looks like the sun was saying right there, if we were to personify that. So the comet died, and so it didn't come back around. It was not around for Christmas, and there you have it. Such is the life of a comet. Such is the life if you're made of ice, I think, is how you need to think about that. And the Kepler telescope, we're not only looking for life on Mars, we're looking for planets that could hold life. The Kepler telescope, whole job in life is to look for Earth-like planets around sun-like stars. That's its entire job. It was conceived, designed, built to do that. Got launched. It's up there in space, 1 million miles beyond the moon in a special orbit. And it is targeting a particular area of the sky looking for sunlight, starlight, of a predetermined list, watching starlight to see if it dips down in brightness and then back up again. It's actually looking for planets that might eclipse in front of the star and come out the other side. So those star systems would have to be horizontal to our field of view. But we have enough, we can measure starlight accurately enough so that if a little dark spot moves across its surface, we can detect that. And it is measuring this, and it came up with 150,000, it's monitoring 150,000 star systems. In them, we have 4,000 candidate planets where the data suggests they're planets, and recently published 1,000 of them have been verified. It's likely that most of those 4,000 will be verified. And so these are planets that you want to get a sense of, again, we're looking for Earth-like planets. Some of them are bigger than Earth. You see Earth in the bottom left-hand corner there. So we're creating a catalog of places you would visit in order if it was time to escape Earth. That could be coming sooner than you think, but last I checked.
On the 186
We lose the glaciers, you have to escape in Florida first. So there we go. These are planets that are small enough like Earth, and they're orbiting their host star in what's called a habitable zone. Not too close to the star, otherwise your liquid water evaporates. Not too far away, it will freeze. That's not useful for life as we know it. So you got to be in this sort of Goldilocks zone, where the temperature is just right. These are Earth-like planets in the Goldilocks zones of their host star, and this list is getting bigger. I don't know if you knew that planet Krypton was discovered. Did you know that? You know that? Yeah. And you know how I know planet Krypton was discovered? Because I discovered it. Okay, that's why I know for sure that planet Krypton was found. I'm bound to that. So I got a call from DC Comics, and they said, we want Superman to visit the planetarium. I'm director of the New York City's Hayden Planetarium. So do you have permission for us to draw it? Do you have permission? I said, well, sure. I'm not going to say no, it's Superman, right? And then they said, I said, why? He wants to come to the planetarium and use our apparatus to observe the destruction of his home planet. And I said, well, it destroyed when he was born, so what are you doing here? Oh, he wanted the light would have taken time to get here. Well, that meant he beat the light beam. So now we got to figure this one out. So I said, if he got here faster than the light beam, that meant, because remember he was launched Moses style, like in a basket from the decaying planet, and then he landed the same age. He wasn't like a teenager when he landed, he was still an infant. So he didn't age at all. So that meant he could have traveled at the speed of light, at which point you don't age, but the other light from his destroyed planet would be there with him. So how do you get here, not age, while your planet takes time to get here, light to get here? And so you got to come through a wormhole. A wormhole. So I said, you got to put a wormhole in your story. And they were fine with that. All right, so he comes through a wormhole, and the light is still chugging its way. And I said, how old is Superman? He said, he's eternally in his late 20s. I said, okay, so I'll find a star that's late 20s light years away, and then by the time he's late 20s, that light will reach him. So I looked and I found a star, in the constellation Corvus, and that is an actual star in the actual sky, 27.1 light years away. And so that would make Superman in that comic book issue 27.1 years old. And so then they said, oh, by the way, can we draw you in this? Now, I'm not going to say no to that either, right? That's what we think about. Yeah, okay, sure, right? And then I'm speaking to the artist, and I said, if it makes no difference to you, I think you could take off a couple of pounds. This would be the time to put me up there. See, could you take off a couple of pounds? And they said, Dr. Tyson, this is the world of the comics. Everyone looks good. So I said, fine. So out comes the comic, we go back to it. Out comes the comic, and so there it is, right? Very cool. So this is a collaboration of artists and scientists to get a story, get some genuine scientific information into the story of a superhero. And it's a fun thing to do. It is pop culture, I think, at its finest, in the sense that you get to have imagination, you get to tap what is known, it enriches the story. And, oh, by the way, this thing about everyone looking good, I thought they apparently didn't take pounds off the operator of the... They could have trimmed him down a little bit too. I've had people come and say, hey, they gave you a really nice looking vest. That's a cool looking vest. I said, excuse me? Do you know who you're talking to? That is my vest. Don't tell me they gave you your vest. Yeah, that's my wardrobe. Okay, so he sees his home planet destroyed, and he's very sad. At the bottom, it looks like he needs a hug. It's sad, because he knew it intellectually, but he didn't see it, and it became real to him when it actually happened. So that was a fun excursion, bringing science into pop culture. I want to remind you that Earth, we talk about, oh, Earth is a haven, and it's beautiful, and it's life-giving, and it's just a Mother Earth, and I just want you to know that Earth actually wants to kill you. Right? There's no shortage of ways Earth wants to kill you. We lost 250,000 people in 2005 to earthquakes, volcanoes, tsunamis especially. The tsunami was earthquake was in Haiti, tsunami in Indonesia. Hurricane, you're no strangers to hurricanes here in Florida. Tornadoes, these are ways Earth wants to kill us. Does a very good job at that. In fact, 98-9% of all species that ever thrived on this Earth are now extinct because of forces wrought upon them on Earth. So don't lie to yourself and say, Earth likes life. The record does not support that. Just saying. And in fact, what do we do when we come here? We build homes and narrow the temperature of exposure, and we stay out of where the sharks are. We don't go into the desert. We huddle around certain areas on Earth that will not kill us. And then we say Earth is a haven for life. If I drop you butt naked in most places on Earth, you're dead 15 minutes later. Eaten. The universe wants to kill you too. In fact, it's way more effective. We have things like, these are rarer gamma ray bursts. These are like the biggest explosions in the universe that were not the Big Bang itself. Supernova explosions, if they happen nearby, that could be bad. It could take out our ozone layer, and we would all, unless you live underground, it would change your skin. Skin cancer. Black holes, it's not a common way to die, but it's an awesome way to die. I composed a poem once about black hole. In a feet first dive to this cosmic abyss, you will not survive because you will not miss. The tidal forces of gravity will create quite a calamity when you're stretched head to toe. Are you sure you want to go? Your body's atoms, you'll see them, will enter one by one. The singularity will eat them, and you won't be having fun. My little rhyme. A black hole coming to go the other direction. All right, solar storms can be bad, but they wouldn't necessarily kill us. What really does kill us are comet impacts and asteroid impacts. These are real, they're in the fossil record, and there are ones out there with our name on it. Here's a representation of the one that took out the dinosaurs. A great space artist, Don Davis, did this for NASA. I want to show this in a high school auditorium. Now, who sits in the front row in the high school auditorium? Yeah, all the nerds sit in the front row, okay. And so a question came from the front row, so I'm ready for an erudite inquiry on this image. And the question was, Dr. Tyson, is that an actual photograph? There comes a time in the life of every educator, we're just ready to give up. And just go to the Bahamas and just say, I've had it. But I wasn't quick enough. I should have said, yes. In fact, the pterodactyl that took this, the ST chip, was still good in the fossil. We pulled it out, put it in the computer, and we were good. These are real. We got hit February 2013. This is a dash cam camera, which they have a lot of in Europe and in Russia. We have many fewer of them here because we would rather have lawyers argue what is true than actual video. So, am I lying or did? No, that's real, okay? So, this video in all, I don't know if all the cars, but many cars. And this is in Russia, in the Ural Mountains, in Siberia. There's a town called Chelyabinsk. Do you see that dot of light in the middle of the screen? That is an asteroid about a third the size of this room. So like 17, 20 meters across, which would be about a third of the area of this room, going 40,000 miles an hour, rendered aglow because it's colliding with our atmosphere, and it's going so fast, our atmosphere feels like a brick wall to it, okay? And you want to know what that's like? Go 60 miles an hour down the highway, roll down the window, stick out your hand. It is hard to hold your wrist rigid against 60 mile an hour air. That's all it is. Now have 40,000 mile an hour air, you stick your hand out, your hand will blow away, and then other body parts, and that's what's happening to this space rock. Here we go. This was February 15th, 2013, caught on a dashboard camera. And this has sound, by the way. So the car is turning, so the dot would be farther to the right if this were a straight road. So we get to follow it a little better simply because this car is on a curved road. So here we go. Now, that was the sound inside the car. And I'm thinking, if I were inside the car, I would say, holy well, this is Russia. Russian. Stoic Russian. Do they experience this every day? What? How come no one's saying anything? So, this Russian meteor, it was it weighed 10,000 tons, going 40,000 miles an hour. The explosive energy in the atmosphere was 500 kilotons, which, by the way, is 25 times more energetic than the bomb in Hiroshima and Nagasaki. But the difference is it exploded 20 miles up, so the energy diluted by the time it hit the ground, whereas the atomic bombs in those two cities were exploded about a half a mile up, calculated to be so that you don't waste bomb energy just making a crater. So they calculated, will explode it higher in the air so that it has a blast wave that can take out the largest radius it can. If it's too high up, it dilutes it and you get much less energy. So, by the way, that was the original definition of ground zero. It's the point below the explosion of a nuclear weapon. So here, we lucked out in a sense because while there were 1,600 injuries in Chelyabinsk, no one died. It's mostly lacerations in the face. You know why? Because people forgot Physics 101. What's Physics 101? Light travels faster than sound. So this is everybody eating dinner or whatever mealtime day it was, and then this bright light comes in through the window. Like Steven Spielbergian E.T. light comes in the window, and everyone says, oh, I wonder what that light is. And then they get up from the table, walk over to the window, look out the window, then the blast wave hits. The physicists are saying, I'm going to wait till the blast hits, and then I'll take a look out the window. So there's a time delay between the two. Most people had glass lacerations on their faces. And so it's a shot across our bow, I think. A reminder that we are in a shooting gallery, the universe wants to kill us, and we need to be mindful of this fact. By the way, there are other bad asteroids, and here's a list. That's just page one. But every one of these asteroids crosses Earth's orbit, which means that it will hit us one day. Every single one of these, we do the calculations on orbits. So there's some more. Each little box is its own asteroid that has an orbit that crosses us. It took me like an hour to figure out to make this open door effect. I think it's pretty cool. It's a pretty cool effect. Yeah, these are just duck next time these things come by. And there's 7 pages of asteroids. And so my favorite poster ever is asteroids, or nature's way of asking, how's that space program coming along? Little Bruce Willis out of just one last bit here, and then I want to have a couple of minutes for Q&A, like a couple of minutes. So I don't know if you tweet or you know anything about it. I tweet 7, 10 times a week, perhaps. I sent out a tweet on Christmas Day when people just lost their minds. They lost their minds, okay? So I put out a tweet. And I tweet all the time, and I try to understand how someone might react. And if the reaction is different from my understanding, I have to wonder what must have happened. I put out a tweet Christmas Day. Later that day comes this headline, ready? Tyson trolls Christians on Christmas. Trolls Christians. I said, what? What did I do? Oh my gosh. So could it be this tweet? By the way, I share cosmic perspectives with people. That's what I do. So whatever is your worldview, I'm going to offer you a bigger worldview to make you feel small, right? That's what a cosmic perspective is. But then you feel big once you realize we're kind of all in this together. So I thought, was it this tweet that triggered ire? Here it is. Question, this year, what do all the world's Muslims and Jews call December 25th? Thursday, okay? They don't celebrate Christmas. So I thought, now, and how many sentences do you get to put Jews and Muslims on the same side of the sentence, right? Hardly ever. So I thought this was kind of, but this had, the way you measure the success of a tweet is how many retweets there are, the excitement level. This is 4,700 retweets. That's a pretty good number. My average is 3,000, typically. So I thought, well, could this have been the one? No? Well, how about this one? And we wouldn't call this trolling. Santa knows physics. Of all colors, red light penetrates fog best. That's why Benny the blue-nosed reindeer never got the gift. Okay? So, is that trolling Christmas? I don't know. I'm kind of celebrating, Santa. That got 14,000 retweets. So people were like digging that. Okay? Then I thought I'd give a deeper history here. A Merry Christmas to all. It was a pagan holiday before Jesus. And then it became a religious holiday in the era of Jesus, which then became a shopping holiday in the United States. Okay? This is real here, right? That had even more retweets. But that's not what freaked people out. Here it is, ready? Christmas Day tweet. By the way, I'm showing this because my tweets became news. Otherwise, I wouldn't show you any of this. It got reported on the evening that people, okay, here, this was the tweet. You ready? On this day long ago, a child was born, who by the age of 30 would transform the world. Happy birthday, Isaac Newton. Born December 25th, 1642. Look at the number of retweets. 81,000 retweets. People lost their minds. And so this is an exactly true sentence, okay? Isaac Newton discovered laws of optics and motion and gravity, and he actually has the benefit of actually being born on December 25th. Nobody knows when Jesus was born. It was assigned to that date later on. People blew their mind, and I got the request to take down the tweet, but it's true, right? And the people said I was trolling Christians. You know what I did 2 days earlier? I took pictures of the Macy's Christmas windows. Why? Because little Alex had a dream that he would visit the planets with Santa, and Santa granted him that dream. So each Christmas window is a different planetary system, and there's Santa with a sleigh visiting them. And I said, kudos to Macy's Christmas windows. And then earlier in Easter last year, I was visiting my sister who raises rabbits, and she has a disturbingly large rabbit called Ozzy. And I said, wow, I'm going to take a picture of Ozzy. And then I did that, and I put out this tweet. Okay? Ozzy and I wish all Christians and bunny lovers of the world a happy Easter. Right? So I knew I'm not trolling Christians. I'm giving information to people. So I said, I got to put a stop to this. And this was the tweet. Imagine a world in which we are all enlightened by objective truths rather than offended by them.